Hello, this is Susan Poss at Spartanburg Community College. I have a cold today, so I apologize in advance for the way I sound. I had a student ask me some questions about Section 8.6 in the Hawks textbook for Math 101. And so I thought I would told her I'd make just a short video to run through these various properties of real numbers and try to make a little bit more sense for you. So the first one is the commutative property of real numbers, and the key word to remember there is the word order. And I always like to tell students to associate the second letter in commutative as an O, and that corresponds to the first letter in the word order to help you remember that the commutative property has to do with the order of things. So the basic way that it is written abstractly is to say A plus B is equal to B plus C. And you see it's an addition operation connecting, sorry, I didn't do that right at all. This needs to be B plus A. So you can see that the operation is an addition operation, and what has changed from the left side to the right side of the statement is the order of the numbers. So how do you apply that practically? Well, what that means is 5 added to 3 is the same thing as 3 added to 5. You can see that on each side, the result would be 8. And it's still an addition operation. It can work with negative 5 added to positive 6 is the same thing as positive 6. And then here's the operation again. It's an addition added to negative 5. And you can see that on either side of the statement, the result would be the same. It would be positive 1. Now, the commutative property for subtraction, let's move over here to for subtraction, does not exist because A minus B is not the same thing as B minus A. And it only takes that simple is 5 subtract 3 the same thing as 3 subtract 5. And of course, this is a positive 2, this is a negative 2, and they are not equal. So the commutative property for subtraction does not exist. It doesn't work, excuse me, for subtraction. What about multiplication? Is it true that A multiplied by B, you see the operation here now is multiplication, is that the same thing as B multiplied by A? Well, let's try an example. Is 4 times 6 the same thing as 6 times 4? And of course the answer is yes, those two things are equal. Does it hold if we have a negative 4 multiplied by 7? Is that the same thing as 7 multiplied by negative 4? And it is. So the commutative property for multiplication exists. The order in multiplication still comes out. If you change that order, you still get the same result. Does it work for division? Is A divided by B the same thing as B divided by A? Well, let's try a simple example. Is 10 divided by 5 the same thing as 5 divided by 10? And you can see that on the left side, 10 divided by 5 is 2. On the right side, 5 divided by 10 is 1/2. And these things are definitely not equal. So again, there is no commutative property for division. So it only exists for addition and for multiplication. And when you answer questions about this, you are expected to also identify the property and the operation. So don't just say commutative property. Say commutative property of addition or commutative property of multiplication. Okay, here are a couple of quick examples for you. Is x plus 14 the same thing as 14 plus x when x is equal to -4? So this side we get a positive 10 and on this side we also get a positive 10. So there's an example of the commutative property of addition. And then the second one is 5 times x the same as x times 5 when x is 2. And you can see we get a 10 on the left-hand side and we get a 10 on the right-hand side. So yes, this would be an example of the commutative property of multiplication. So that's just a quick overview of commutative. Those of you who are headed into elementary school teaching, it's going to be important for you to be able to maybe not so much teach these to little children, but be able to understand how they work. Okay, the second one is the associative property. And the key word here is grouping. So if you know that commutative has a second letter of O and that goes with the order, then you know the other one has to be grouping. So associative property is a grouping. And it takes three things, three quantities to illustrate this. So let's say we have an A plus B plus C on the left-hand side. And notice I'm not illustrating order right now, so I'm keeping the same order, A plus B plus C on both sides. What I am going to show you is grouping the B plus C on the left side and grouping the A plus B on the right-hand side. So you see I needed three numbers, three quantities here. So an example, let's just throw some numbers down here. So 5 plus 7 plus 2, that's 5 plus 9, which is 14. Is that the same thing as 5 plus 7? Again, keeping the same order, grouping it differently. And the answer is yes. So the associative property for addition, that's an example of it. Same kind of problem. You're going to see that this does not work. So if I group these two and then come over here and keep the same order, because I'm not working on commutative, I'm working on associative, which is a grouping, am I going to have a problem with that? So let's take the same three numbers. 5 for A minus 7 minus 2. Is that the same thing as 5 minus 7 minus 2? All right, so in here we have 5, and 5 minus 5 is 0. Over here we have a negative 2, and negative 2 minus 2 is negative 4. So, no, the associative property does not work for subtraction. All right, so let's try the associative or grouping property for multiplication. And this one is A times B plus C, grouping the B and the C, and notice I'm keeping the same order, A, B, and C, and this time I'm grouping the other two values. So same order, A, B, C, grouping B and C on the left side and grouping A and B on the other side. So let's make up some numbers. Let's say 2 times 5 times 3, question mark, is that the same thing as 2 times 5 times 3? So this would be 2 times 15, which would be 30, and this would be 10 times 3, which would also be 30. So you can see that associative property holds for the operation of multiplication. And this one's kind of hard for me to illustrate, but let's say 10 divided by 2 divided by 2. I'm trying to think of something that'll work out fairly easily. Is that the same thing as 10 divided by 2? Oops, sorry. We group these two, divided by 2. So you see again, it's the same order I'm just changing the way it groups. So this would be 10 divided by 1, which is 10. And this would be 5 divided by 2, which is 2.5. And you can see that these are not equal. So again, the associative property for division does not stand. Only for addition and multiplication. And again, you need to be able to identify the operations. So here are a couple of quick examples when x is 5. 3 times 6 times 5 equals 3 times 6 times 5. So this is 18 times 5, which is 90. And this is 3 times 30, which is also 90. So that's an example of the associative property for multiplication. So again, you see me identifying both the property and the operation. And this one's basically the same thing. I don't know why I didn't throw an addition one in here. Let me see if I can get one of those. Let me do one more. What if we had 4 plus parentheses 6 plus 5? Is that the same thing as 4 plus 6? We'll group those two. So here's the 11, and here's the 10. So this would be an example of the associative property for addition. Okay, so I hope you see that you need to identify both the property and the operation. The next one that I think you're most likely to use is the distributive property of multiplication over addition. Most students are familiar with that. So what you're doing here is you're taking the multiplier out in front of the parentheses and distributing it into, and this, what I have written here is not correct, into the parentheses. So here this is 12 times y and 12 times 3. This is 11 times -4 and 11 times 3. So you can see how that works out. Another way, of course, to work this one is to do what's inside the parentheses first. And, of course, you come up with the same result. So these are examples of the distributive property of multiplication over addition. The identities are pretty simple once you understand. The identity for addition is 0. It's called the additive identity, or the addition identity element. So if you have 5 added to 0, it's the same thing as 0 added to 5, and that is 5. So if you're adding 0 to something, you get identically what you started with. -15 added to 0 is the same as 0 added to -15, which is -15. So 0 added to anything, that's an identity element, and you get the same thing the other number that you started with. So the identity for multiplication is the number 1. 0 for addition, 1 for multiplication. Multiplicative identity. So if you take 5 and you multiply it by 1, that's the same as 1 multiplied by 5, which is still 5. So you can see multiplying by 1 gets you identically what you started with. Adding 0 gets you identically what you started with. So let's see, -3 times -4 is the same, oops, excuse me, I want a 1 in here. -3 times, sorry, my head is not working very well today, I apologize. It's the same as 1 times -3. So 1 is the identity for the operation of multiplication. I think this is the last one, yeah, the inverses. You use inverses when you solve equations, so you're going to see these inverses come up in the next chapter when we start solving equations. So the inverse, if you're in addition, is the opposite. So the additive inverse for -5 is +5. The additive inverse for +16 is -16. So these inverses are opposites. They're on opposite sides of the number line. And where you're going to see this is when you start solving equations. And I'll say, okay, the opposite or the inverse of adding 12. And you'll see me do an opposite operation. I'm sure you've seen this before. So when you're solving and you're working with an addition operation, you use the opposite sign. And this is where it gets a little confusing. So if you're working with the inverse for multiplication, it's the reciprocal. So the multiplicative inverse for -5, notice the sign here, remains negative, and the number is the reciprocal, or the number flipped upside down, because there's actually up underneath this 5 a 1. So the multiplicative inverse for -2/3 is -3/2. And where you're going to see that coming up is you will have maybe something like 4/5 x equals 10, and in order to solve it, you will be using a multiplicative inverse. Notice how I kept the same sign, it was positive. The reason you're going to be doing that is because these things are all going to cancel out and give you a 1x, which is what you're going to be looking for, 50/4 or 25/2. So multiplicative inverse is going to be the reciprocal. Both of them will have the same sign. Additive inverse is going to be the opposite, the same quantity, but one will be a positive quantity and the other will be a negative quantity. Okay, so that's a good place to stop. I hope that will help you a little bit with section 8.6.